Good morning, lesson GS student. This is your math teacher, Monsieur All. This is our 6th week in quarantine. Our lesson today is about lines and planes. In fact, today we are going to learn how to determine an equation of a plane. First of all, what do we mean by a normal vector to a plane? A normal vector to a plane is a vector held or have the same direction as a straight line perpendicular to a given plane. And in other words, it is held by a straight line orthogonal to all the straight line in the plane. So suppose that n also is its coordinates u, v, and w, and n must be non-zero vector. How I can determine an equation of a plane? In fact, since n is orthogonal to the or perpendicular to a plane, or held by in fact by a line perpendicular to the plane, then if we take any vector in the plane, the scalar product of n dot this vector, whatever the vector here is, equal to 0. We know that if two vectors are orthogonal, then their scalar product equal to 0. So if A is a point in the plane and M is any variable point of the plane, suppose that this point is A, and M is any variable point in this plane, so AM dot N equal what? Equal to 0. Why is that? As I said, since N is orthogonal to the to all the straight lines on the plane. First of all, we determine the coordinates of the vector AM, x minus xa, y minus ya, z minus za. Then we take their scalar product, so x times x plus y times y plus z times z equal to 0. We obtain ux plus vy plus wz minus uxa plus vya minus wza equals 0. Suppose that r equal this quantity. By the way, if we have the coordinates of the vector and the coordinates of the point we obtain directly that this is constant. What do we mean by constant? Independent of any unknown as x, y, and z. So r equal uxa minus vya plus wza. So at the end we obtain the relation, the formula ux plus vy plus wz plus r equals 0, which is an equation of a plane. This formula is the equation of the plane, where u, v, and w are the coordinates of the normal vector. U is the abscissa of the normal vector, v is the ordinate, and w is the elevation of the normal vector. So an equation of the plane P passing in any given point x, a, y, a, z, a, and whose normal vector n u, v, w is of the form ux plus vy plus wz plus r equals 0, where r equal minus uxa minus vya minus wza. Example, suppose that we have the vector n of coordinates 2, minus 3, 1, and the point A 4, 1, minus 2. If they ask us to determine the equation of the plane, so directly I can do what? I can determine directly r. R equal what? R in fact equal minus uxa vya wza, and we multiply 2 times 4 plus minus 3 times 1 plus 1 times minus 2, and of course we take minus into this, so we obtain in this case r equal minus 3 and the plane 2x minus 3y plus z. Why 2x? Because this 2 is u equal 2, v equal minus 3, and z equal 1, and r equal minus 3. Now, this is for you to solve. Example 2. They ask us to determine a normal vector of the plane 2x plus 3y minus 2z plus 1 equal to 0. Simply the normal vector, in fact, we have an infinity of normal vectors of any plane, because any vector perpendicular or held by a straight line perpendicular to a plane is also a normal vector of the plane. And any vector which is collinear with n is also a normal vector to the plane. Here, this is u, this is v, this is y, so, z. So simply, as you see here, 2, 3, and minus 2, in fact here, it will be equal the u, v, and w. Then what can I deduce in this case? Then n, the coordinates of the normal vector, R2, 3, and -2. Remark, as in grade 9, when we have a line passing through the origin, we obtain y equal ax, b, it will be equal to 0. Here, if the plane passes through the origin, then the constant r equal what? 0. Also, this question is for you to solve. Determine a normal vector n of each of the following planes. In fact, you can determine more than one normal vector to the plane. Given a, 2, 1, -1, b, and c, they ask us to determine a normal vector to the plane ABC. From the definition of the vector product, we know that if we take AB cross AC or whatever, BA cross BC, whatever, as I said, it will be a vector perpendicular to the plane ABC. Then, directly I can determine the coordinates of vector AB and AC. Then we take their scalar product. We notice that AB cross AC, ijk, -4, -1, 4. We obtain at the end, and 0, 1, 2, we obtain at the end -6i plus wj minus 4k. Then the vector AB cross AC, which is n in this case, is a normal vector of the plane ABC. This question is for you to solve. Here we have some particular cases. What is the normal vector of the plane x or y? In fact, the elevation, which is the z-axis, is perpendicular to x or y, and the unit vector of the elevation is k. So in fact, I can take for the plane x or y normal vector k, and the equation of this plane, it will be x equals 0. If you remember from grade 9, the equation of the abscissa axis, since all the points are on the abscissa axis, the equation of the abscissa axis was y equals 0. Also here, when we have point in the plane x or y, then their elevations is equal to 0. All the points, they have the same elevation, which is equal to 0. Then the equation of this plane is z equals 0. Similarly, for x or z, y or z, we have normal vector j and y equal to 0 when we have x or z. Y or z, the equation of the plane x equals 0, and the normal vector is I. If a plane parallel to x or y, as in fact also in grade 9 when we have a line parallel to the abscissa axis, then its equation is y equal 2, y equal 5, whatever. So here, if P is parallel to x or y, then the equation of this plane is z equal a constant, or in fact we can write it directly, z plus d equals 0. Similarly, for a plane parallel to x or z, it will be y plus d equal to 0, and a plane parallel to y or z, which is x plus d equal to 0. Now, if they ask us to determine an equation of a plane passing through 3 non-collinear points, we know that to determine an equation of a plane, I need a normal vector and also I need a point. Of course, here I have 3 points. Like, what I'm going to do? First of all, we need to determine a normal vector. If I have 3 points A, B, C, non-collinear points definitely, then a normal vector is defined by AB cross AC or BA cross BC or CA cross CB. So the vector AB cross AC, it will be a normal vector of the plane. Then, first of all, we determine the vector n. Then we take any point in the plane and we determine the equation, or by using am dot n or by using substitution. In fact, since am dot n equal to 0, and I know that n is AB cross AC, so directly I can use the formula am dot AB cross AC equal to 0, which is the mixed product. Then we know, as I said, this is n, the normal vector AB cross AC equal n, and an dot am equal to 0. So simply, since n, I can replace n by AB cross AC. Then am dot AB cross AC equal to 0. Now, equation of a line passing in a given point and parallel to non-parallel lines. What do we mean by non-parallel lines? Or they are intersecting or they are skew. Skew, that they cannot be in the same plane. Let R1 and R2 be two director vectors of the two non-parallel lines D1 and D2. A normal vector of a plane parallel to D1 and D2 is n equal R1 cross R2 in the same way as for AB cross AC. A point M belongs to this plane if and only if AM dot R1 cross R2 equal to 0. So an equation of the plane P passing NA and parallel to D1 and D2 is a relation of the form UX plus VY plus WZ plus R equals 0, which is obtained from the relation AM dot R1 cross R2 equals 0. Remark, if N is a normal vector of a plane P, then any vector collinear to N in the form alpha N is also a normal vector to P for any alpha belongs to R star, as I said in the beginning of this session. Thank you. This is all.